Hi guys, welcome back to my YouTube channel. This is Tanushree. Okay, in this video I taken the topic laws of motion in a physics stream. It was very interesting and basic topic for physics. And which involves the Newton's laws of motion and some conservation momentum principles and forces and their types as basic definition of that and what was the force when it acted. So these are all going to explain in this video. So please do subscribe to my YouTube channel and click on the bell button icon that will notify you for my upcoming videos. So in that I'm going to first explain about Aristotle fallacy, and after that the Galileo experiment, what he did and what he come across from the Aristotle conclusions. And after that we are going to know the common definitions of the forces and their types and what about the forces and fundamental forces and state of the motions. Okay, what was the state of motion is present in that and impulses and the conservation momentum principles. So we are all going to study in this video. So please do like, share and comment on this video. Subscribe to my YouTube channel. Click on the bell button icon that will notify you for my upcoming videos. Let's start the video. So before going to the laws of motion topics, first we have to know the origin of the laws of motion. So first the Aristotle, who came to some conclusions on that laws of motion, that is heavier objects falls faster than the lighter objects, and he believes to keep a body in a motion we need to apply the external forces. According to him, he believed in his own experience that heavier object falls faster than the lighter objects in a smooth inclined plane. Okay, uh, he considered the smooth inclined plane and put the object on that, and the object will rolls on. Okay, then he uh, believed in his own way in having that heavier objects falls faster than the lighter objects in the small inclined plane or a smooth inclined plane. Then he also believed that to keep a body in a motion we need to apply the external forces in the smooth inclined plane. That was the Aristotle made conclusion that are all justified by his practical. So this was concluded or corrected by the Galileo. So what he did we will see now. So, until Galileo, the Aristotle made it conclusions that are believed by everyone. So, after Galileo, what he did in his experiment and what was the conclusion come across from this Aristotle. So, we are all seeing in this video. Okay. So, firstly, Galileo, what happened? Galileo taken the small inclined plane and put the object at rest. So, he not at all applying any force, anything. Then the object reveals and come to its final position. Okay, so he observed that the change in a velocity from its initial position to the final position, there will be a no change in a velocity, and also he observed in the change in time. Okay, so when it is in a rest position, the time will be same as it is in its final state position. So he concluded that change change in a velocity is equal to change in a time. That is nothing but the change in a velocity of its initial state is equal to the change in the velocity in the final state, and also the time. Okay, the change of the time in the initial state is equal to the change in the time of the final state. So he concluded the change in a velocity of an object of an initial or a final state is directly proportional to the change in the time of its initial state or a final state. So here he taken change in a velocity is equal to change in a time of a both initial and a final state. Okay, so change in velocity, it is nothing but delta v is equal to change in time, it is nothing but delta t. So what he did is he put the delta t into the LHS. So what we get, delta v divided by delta c is equal to constant. So there is no change in the velocity and time taken by the object to move from its initial state to the final state. Okay. So by this experiment, Galileo came to the conclusions that firstly, he concluded that the motion is of a uniform acceleration. Because why? Because there is an equal change in a velocity in an equal interval of time from its initial position to the final position that he observed in this experiment. So then he proposed an idea that motion is of a uniform acceleration. Okay, if in the case of a different masses, Okay, in the different masses. So Aristotle said, what he said, heavier molecule falls faster than the lighter molecule, right? So in that he works on this experiment, Galileo works on this experiment and came to a conclusion that it is independent of mass. Okay, how it is independent of mass? In case of a different masses, what happens when we put the different masses? Okay, if we put the heavier mass, let us assume that. Okay, if we put a heavier mass, what happens? It falls down in the same way with the same velocity and the same time. Okay, what happens if we put a lighter mass object? So that is also moving in a same velocity and the same time. So there is no change in the velocity or a time. Okay, and it doesn't depends on the mass. So Aristotle said it depends on the mass. Okay, heavier molecule falls lighter than a lighter. Okay, so Galileo told that it is an independent of mass, not a heavier, not a lighter. Okay, so he concluded like that. Next part, he going to conclude that force is not needed to keep an object in the motion. So if we put an object in this small smooth inclined plane, then we will don't want to apply any force on that. It will falls down with their own power. Okay, because the surface is a smooth inclined plane. Okay, so these are three conclusions which are made by Galileo. And when we compare this conclusion with Aristotle conclusion, it is very good that he obtained for us. Okay. So as you can see, Aristotle said that heavier objects falls faster than the lighter ones. But Galileo said, no, it is depends on the surface. It depends on the inclined plane, how the plane is. So if the plane is in a straight line, then we have to apply the force. Okay. If the plane is inclined, okay, if the plane is like this, inclined, then we don't want to apply the any force for the object to move it from initial state to the final state, and there will be no change in the velocity and the time interval taken by that object. And so he concluded the motion is of a uniform acceleration because they are equal in the change in a velocity in equal interval of time, and force is needed to keep the object in the motion. So this is what the three conclusions made by the Galileo. So these conclusions were inspired by the Newton, and he made the three laws, that is Newton first law, second law, third law. Okay, in these three law, the Newton talks about qualitative discussion of the force and its effect in the Newton's first law. Okay, in the second law, he going to explain or discuss or talk about quantitative discussion of the force and effects. And in third law, he talk about existence of the forces in the space, like collision of the objects, object A, object B. So when it collides, what happens? After collision, before collision, what happens? These are all studied in the Newton's third law. So we will move on to the next. So before going to the Newton's law, we have to know the state of motions. So we move on to that. So before going to Newton's, first we have to know about the state of motion. So what was the state of motions are there? Okay, we will move on through that. If if an object is having a velocity when it is at rest, okay, then it is called one of the state of the motion. So one state of the motion is when the object is placed in a straight line or anything surface or a plane, okay, which is at rest. We are not at all applying any forces or external agents. So it will present at present in that rest. Okay, that will be one of the state of the motion. Okay, if an object is moving with the constant velocity, then it is one of the state of motion. So when we apply the force or some external agent will apply to the object, then it will move with the constant velocity. So the moving with the constant velocity, it is one of the state. So at rest is the one of the state of motion, and moving with the velocity or anything, it will be another state of motion. These are two states of motion we have to know in this topic. So forces and their types. So what is a force? A push or a pull. Okay, a push or a pull which can change the state of motion of an object and also shape of an object. This is what the force. Okay, if we are pushing the object, okay, then what happens? The force has both magnitude, okay, which can change direction also. Say so the force having both magnitude and direction. Okay, a push or pull can change the state of motion and also change the shape of the objects too. Okay, if we apply the more force, what happens? It gives the more changes, right? If we apply the less force, it will give the less change. Like that, how much we applying force, that will be a outcome of the changes, as we can see. Next, has magnitude and direction. We know that types. Okay, we have know the fundamental forces, right? Which are those gravitational forces, electromagnetic forces, and weak nuclear, strong nuclear. Okay, in that some of the input types, so in that we are studying the some of types of the forces. That is, first one is weight, friction force, and nuclear reaction force, contact force, tension, spring force. These are all forces which will comes under these fundamental forces. Okay, here weight, if we it is due to the gravitational force. Okay, if we place the object in a some plane, okay, rough or any smooth surface, if we place object in that plane, so what was the weight of the object depends on, it depends on that the surface. Okay, it holds whole object weight. Okay, that will depends on that plane. So it is an best example for the gravitational force. It is weight nothing but the gravitational force. Okay, as we know. Next, friction force. Friction force means if we trying to move object, okay, with some velocity, okay, it is difficult to transform back. So there will be opposite force called as friction force. Okay, the it resists the motion between the surfaces. Okay, it resists the motion between the surfaces. So friction force which resists the motion between the surfaces, and this way, this force which is in the form of fundamental force, that is electromagnetic force, this is the gravitational force, and remaining all forces are the origin from the what electromagnetic forces in nature. So next type of the force is tension. Okay, it is a transmissible force in the string. Okay, consider a wall. In that wall, a button is placed or a hook. Consider a hook. Okay, in that hook, a rope or a string. Okay, which will be placed, and that string will be in some man's hand. Okay, he tried to drag that string or a rope. Okay, so then what happens? There is a tension creation. Okay, there is a tension is produced. Okay, that due to that tension, what happens? This button breakdowns. So that tension of the force we will call it as type of the force. Okay, this is what the basic example for this tension force. And fourth one is spring force. So it is a restoring force, as you all know, in the spring. Okay, it is denoted as Fk. Okay, consider the spring, okay, with the mass m. Okay, the when the spring is compressed, then it get restored force. Like if we compress the spring, okay, then what happens? There is a restoring of the force, right? So that force which is called as the spring force, the restoring force in the spring is called as spring force. This is one of the type of the force. So we will move on to the Newton's first law of motion. As I told you, Newton's get inspired by the Galileo's three conclusions what he made, and for according to that conclusions he made the three laws: first law, second law, and third law. And these laws are depends and talks about the qualitative and quantitative aspects. And third law, which going to we can know about the existence of pairing of objects, like collisions, what occurs after collision, before collision, that I told you. Okay, first we will move to the Newton's first law of motion. So it's also called as law of inertia. So first, why? Because I tell you later. First we will move on to the statement. Okay, every body continues to be in a state of rest or in a state of uniform motion in a straight line unless compelled by some external force. So according to the Newton, here some object or a body considered, as we consider some object or a body which is placed in a straight line, okay, which is at rest. This is one state of motion, and which one is moving with a velocity, constant velocity, that will be another state, as I told you, in the state of motion. Okay, so every body continues to be in a state of rest or in the state of uniform motion unless compelled by some external force. So when the force is applied to the object which is at rest, okay, then only it can change its states to the second state, that is in moving with the constant velocity. If we don't apply any force or external agent to this rested object, then it will not move from its state to another state. So according to for his first law, he describes that we have to apply some external forces for object to move from its one state to the another state. So this is what the Newton's first law of motion says. Okay, here I said Newton's first law of motion is also called as law of inertia. Why? Because inertia means laziness. Okay, here the object is having not at all any forces or not at all any motioning ability. So what happens? It will never regret. Okay, it will never transform from one state to another state. So we have to apply some force for this lazy object. Just we consider like that, then we will understand better. Okay, so the object is very lazy, so we have to put the force on that, then only it will move from one state to other state. So it is called as law of inertia. So it is also called as inertia. Okay, this is what the Newton's first law of motion. Next we will move on to the second law. Move on through the Newton's second law of motion. So what's the statement? I had told you Newton's second law of motion, which talks about quantitative discussion of the forces and its effects. Okay, you have to take down that point. Statement means the rate of change of momentum of a body is directly proportional to the net external force of a body in direction of net external force. Once again, the rate of change of momentum of a body is directly proportional to net external force on body in the direction of a net external force. What does it means? Means here an object, considering an object on the straight line with a mass m and moving with a constant velocity or some velocity v. Okay, mass, wherever there is a mass and velocity, there will be a momentum occur, right? P is equal to mv, as we know, linear momentum. Okay, so the rate of change of this momentum of a body occurs when we apply the external force on that body in that direction of the force, what we applied the force. Okay, this rate of change of momentum of the body is directly proportional to what? Net external force. So net external force means, net means sum of the forces. Okay, sum of the applied forces. There will be application of the two forces, one forces. So we have to call net. So sum of the external forces. So external force, which can be denoted as F, which is directly proportional to the rate of change of momentum, where P is the momentum. Okay, P is equal to what? Mass into velocity, as we know. So what we have to do, we have to apply the P m into v in this formula. What the equation we have obtained in the second law. Okay, F is equal to d of dt into mv. So we have to differentiate this. So we know the differentiation of u into v, right? U into differentiation of a v. Okay, here u means m, v means v. Okay, so u into differentiation of a v plus v into differentiation of m. So we put that one u and we have to differentiate the v term, plus we have to put v term and we differentiate the u term, reciprocal. Okay, then what we have to do, if the mass is constant, then okay, here the mass is a constant term. Velocity, dv by dt means what? Acceleration, right? The rate of change of velocity with respect to the time, it is a acceleration. We all know the acceleration common definition. Okay, so we have substitute this by ea. Okay, here the differentiation of m means constant. Differentiation of constant, what? 0. This whole term becomes 0. So we substitute the a here, m into a. So we obtained f is equal to me. This is what the second law of motion says, f is equal to me. Okay, so this is the derivation for the force. Next we will move on to the impulses. Okay, impulses which comes under the Newton's second law only. So it is defined as a certain amount of a force that we apply for a certain amount of time to cause the change in the momentum. That should be calculated by this phenomena. So what happens here when consider it as a ball. Okay, when the ball hits the wall, okay, that will be a positive. It hitting the wall and coming back to their original state. Okay, after hitting this, the wall hits it back. Okay, wall hits the ball to their back position, so that will be a negative. Okay, what we conclude this year, we can estimate that ball can hit the wall and it can come back. Okay, so what was the velocity, in how much velocity it hit the wall, in how much time interval it hit the wall? Okay, that would be calculated by using this impulses. Okay, so it is certain amount of forces that we apply for certain amount of time, okay, to cause the change in the momentum. So we have to calculate it by this impulses. So to know the how much velocity and how much time interval taken by that ball to hit the wall and come back to its position. Okay, so here J represents the impulses. F means here is a force. Okay, then T means time. Okay, the change in the time from hitting to a wall and came back to this position. So we have to calculate using this impulses formula. So from Newton's second law, we will take F is equal to ma. Okay, a means what? Delta v by delta t, change in the velocity with respect to change in the time. Okay, what we have to do, we have to take this delta t into the LHS. F into delta t is equal to m into delta v remains. Okay, m into delta v means, okay, mass into change in the velocity, it represents the momentum, right? So change in the momentum. Therefore, the force, the impulse, okay, F into delta t means what? Impulses, right? The impulses which is equal to change in the momentum. Okay, this is what the impulses topics involves, these forms, which will very important and it is very easy to understand. Okay, Newton's third law of motion. In that we will go through the statement. For every action in a nature, there is an equal and opposite reaction. As we all know this law, wherever can ask, we will tell it in a minute, in a seconds of time, because we know that very much. So, but we don't know the proper definition for this. So let get it in a best example, that is rocket. Okay, let an object A exerts an force on object B. What happens? The object B also exert a force on object A with equal magnitude and opposite direction back on that object A. So the force results from the interactions. Okay, I had taken the good example rocket. Okay, rocket moves forward by expelling the gas backward at a high velocity. Okay, what happens here? By expelling the gas backward by the rocket, it is an action. Okay, due to that expelling, what happened? The rocket moves forward. This is what the reaction. So for every action, there will be an equal in the opposite reaction. So the action in the south direction, but the reaction in the north direction. Okay, so it depends on the velocity of expelling gas. It also in the same velocity it will move forward. This is what the best example for the Newton's third law. Next we will move on to the conservation of momentum. Okay, for two or more bodies in an isolated system acting upon each other, their total momentum remains constant unless an external force is applied. Therefore, momentum can neither be created nor be destroyed. Let us consider the body of a mass m1 with the initial velocity u1 and another body with a mass m2 and initial velocity u2. These two having the momentum. Okay, wherever there is a mass and a velocity, there will be a momentum, linear momentum or any other momentum. Okay, so in the before collision state, there will be a momentum for each mass of the body. So after the applying some external force on this isolated system, there will be interaction of the two bodies m1 and m2. So then what happens? The momentum of these two bodies remains constant. Then after applying some external force, then what happens? The interacted bodies are separated and with their final velocity v1 and v2. So again back to their momentum. state. Okay, so here what happens, the momentum which will be present in the before collision, after collision what happens, there will be a constant in their momentum. That is nothing but there is no momentum between that. Okay, after the expel or after the separation of these two bodies, what happens, there will be a momentum is created. So that is the conservation of momentum. Law of conservation of momentum says that momentum can neither be created nor be destroyed. This is what the principle of the law of conservation of momentum. So I hope this video helpful for you. So thank you for watching this video. Please like, share and comment on this video. Thank you.